Welcome to our Week 1 lesson on compounds, where we will explore the fascinating world of chemical combinations. The periodic table is a remarkable tool that organizes all known elements. It was first proposed by Dmitry Mendeleev in the 1800s and has evolved with contributions from many scientists. Each element has a fixed position, arranged by increasing atomic number, and its position tells us whether it's a metal, non-metal, or semi-metal. The modern periodic table is a tabular arrangement of elements, organized by increasing atomic number. It consists of 18 vertical groups and 7 horizontal periods, providing a comprehensive layout of chemical elements. The periodic table contains 118 elements. By examining the table, we can determine the percentage of metals and nonmetals, offering insights into the composition of the universe. Elements can be identified in 3 ways: by their unique name, chemical symbol, and atomic number. These identifiers help us understand and categorize the elements effectively. Atomic number and mass are crucial for understanding elements. For example, chlorine has an atomic number of 17 and a mass of 35.45, which helps us identify its properties and behavior. Metals are shiny and malleable, nonmetals vary in state and properties, and semi-metals combine characteristics of both. Understanding these properties is essential for studying chemical reactions. Compounds are formed when 2 or more elements are chemically bonded. This bonding results in new properties, distinct from the individual elements, as seen in water, methane, and calcium carbonate. Chemical reactions transform materials into new substances with different properties. Reactants form products through the rearrangement of atoms, highlighting the dynamic nature of chemistry. Compounds are named based on their elements. Chemical formulas use symbols and numbers to represent the composition and ratio of elements, providing a quick way to understand their structure. Water, composed of hydrogen and oxygen, is a classic example of a compound. The formula H2O shows the ratio of atoms, illustrating how elements combine to form new substances. Compounds with 2 elements often end in "-ide", while those with 3, including oxygen, end in "-ate". These naming conventions help us identify the composition of compounds. Each compound must have a unique name to avoid confusion. For instance, carbon monoxide and carbon dioxide, though similar, have vastly different properties and effects. Carbon monoxide and carbon dioxide both contain carbon and oxygen, but their unique names prevent confusion and highlight their distinct characteristics, crucial for safety and clarity. To name a compound, identify the elements, write the metal first, and adjust the ending of the second element to "-ide". This systematic approach ensures clarity and consistency. For compounds with 3 elements, one being oxygen, change the ending to "-ate". However, there are exceptions, like sodium hydroxide, which defy these rules, showcasing the complexity of chemistry. Polyatomic ions add another layer to compound naming. Understanding their formulas and names, like sulfate and nitrate, is essential for mastering chemical nomenclature.